cleaned out all the UV sand and the resulting films and crap that accumulated in there. I replaced it with new distilled water, which was mostly distilled. It had 4 parts per million due to the crap left in the, I guess, that was left over that I didn't get out from the UV cleanup. And then that black powder that you see in there, the black stuff, is a single-walled carbon nanotube. And I just dumped that in. I had a little vial of it. Focus, solid malt, CNT, 100 milligram, 300 milligram. Anyway, that's what's in there. And I haven't turned it on yet. This will be the first time turning it on, so let's go ahead and turn it on and see what happens, if anything. Nothing! So I wonder if over time, with the silver in there and the carbon in there, if it'll break down into the water. Actually, something is happening. Check that out. Taking form. I'm curious. Discharge, it's sort of elongating itself. It's like a slow-mo building of liters over multiple discharges. When you hear the large, loud discharge, that's when it's arcing clear across the surface of the water and hitting the other side, the other electrode on the surface. Everything else is just hitting into the water. That's interesting. Nothing happened right away there, but then after a little bit there, everything seems to bunch up. You know, that kind of looks like what you see on the beach from the hydrology, just from the waves working the sand, right? Depending on different densities, it sort of clumps up. This camera doesn't exactly have the best resolution. Let's see. So it kind of like built leader that goes like from here into there, and then all of the rest of that is kind of stirred up. So let's see. Let me stir it up and let's reproduce it real quick on the same thing here. So I'll use a little stick. There's some resistance, so it's almost like it's hardened into those positions. It's clumped together. It has actually, it's clumped together. Curious. Alright, we got that good and messed up. I don't see any good straight lines. Let's make sure that's all broken apart. Spread out. Alright, let's try this again. See what happens. So that's pretty interesting, huh? It's again made lines, striae, and the striae run between the polarizations here. The lines are aggregating in lines that run on the vector between these two electrodes. And as they line up like that, it's actually hardening into place. They are a little bit rigid when I try and break them up, so it's like they're stuck. So I guess that makes the waves on the beach an orthogonal phenomena, being the hydrology aspect, which is a pure current version, which is in the balanced ambient state, which is represented by the water itself washing on the beach, because the lines form laterally, matching or in parallel with the actual wave front that hits the water, or that hits the beach, right? So the lines go along the actual plane of the wavefront, which is what deposits the lines on the beach, which is the pure current aspect, which is creating the pure current depositions along the volt disparity that must be present. This is the waveless aggregation phenomena, although there's probably a wave there from the shock wave as well as the discharge of the arc producing any other sort of polar aggregation inside there. It's because the way it's set up, probably, that it's able to aggregate like that, right? Because this is, my main gap is on the negative side, negative common, over there inside that ball, trying to keep the noise down, and the positive common is on this side. They both have a coil. These are the primaries, and then they've both got a secondary. This is the positive secondary, this is the negative secondary. And that's what's feeding out on either side and gives me, it's probably over 100,000 volts, at least, I don't know. I mean, these meters only go up to 40,000 volts DC each, and when it's running in this particular configuration, these meters are both pegged off the 40,000 volt end, so. And they're measuring between this side's negative terminal and the common positive, and then the other meter over there is measuring between the common positive and the other side's negative, and that's the two negatives that meet and make the spark gap. And that's carbon nanotubes again, so interesting stuff, huh?